movement diagrams. Now you see a table here now, and we will be going again through the comparison now between flexibility and stiffness method. Comparison between the two, and you see the resemblance also in this. One is actually the resemblance in the steps I'm saying. Otherwise, one is just reverse opposite of the other one, reciprocal of the other one. Now, step number one, determine the degree of statical indeterminacy. This is in case of the flexibility method. What we do in case of the stiffness method, determine the degree of kinematical indeterminacy. Choose the redundant actions here in flexibility method. Here, choose the redundant joint displacements. Now, to obtain the basic determinate statical structure, here the basic kinematic structure, and compute the DRS values here. DRS values here are, and here we find out the AD values. AD values are calculated in step number one. Here you can see statical indeterminacy. Why? If you remember, we removed this AR. This was the redundant action declared. Here the redundant now joint displacement declared is theta 8b, rotation 8b, and it is designated by D. Assign coordinates to the chosen redundant. So one, and this was also one. Assign coordinates to the independent joint displacements. Next step now, we put them under the load. When we place this, in case of the flexibility method, step 3 we are discussing, release structure is under the actual load now, and corresponding to the AR, this displacement was calculated, and it was given the name of DRL. This magnitude is placed under the actual loads, and corresponding to the unknown joint displacement, now the action is calculated, and that is known as ADL now. This is ADL, action corresponding to the displaceable joint due to actual loads. So this is calculated. Next is the calculation of the coefficients now. This again, on the left-hand side, fourth step was what? We put this structure corresponding to the redundant action by a unit value, and we calculated the displacement. And that displacement was giving us the flexibility coefficient. This is step number 4, not 2. So what we will be doing here, we will compute the action at the coordinates and the restraint structure due to the unit redundant displacements now. What we do corresponding to unknown giant displacement, now we give a unit rotation and we calculate the action produced now corresponding to the unknown giant displacment, and that is giving us the stiffness coefficient value. So this S will be calculated. Here F is calculated, here S is calculated, here it was displacement, here it is action. Next, in this step number 5, let's say the comparison, here compatibility condition is applied in this flexibility method, while in stiffness method, the equilibrium condition will be applied. Hold on for a second, I got a call, so I'll be with you shortly. Okay. So now here, as I said, in step number 5, we use compatibility condition at the coordinates to determine the redundance. AR were calculated, and here we apply the equilibrium conditions at the coordinate to determine the independent displacement. So here the unknown displacements are found by using the equilibrium condition. Step number 6 is the same compute member and actions, and here also we are computing the member and actions. We draw the shear force diagram in flexibility, so we draw the shear force and bundle movement diagrams in the stiffness method also.